Okay, here we have been given a reaction and it says that this compound, when it reacts with two unknown compounds X and Y, gives three products and H2O. We've been asked to identify these products X and Y. So I have no clue how to do this. What?
You have to first, sometimes it is very good, useful. If we look at the options, we might get a hint what the reactions are they talking about. If you look at the options, we are looking at ketone, everywhere is ketone. So this must be related to ketone somehow. So I am writing a general performer here, pH, NH. As soon as I got the hint that it might be related to ketone, so I know this kind of reaction, R1, R2, like H2O moves out.
Yeah.
We remove H2O from this and we get the resultant compound pH, NH, a lone pair because it has a lone pair.
Yeah.
And double bond here, this double bond which was formerly with
to that carbon.
Yeah, carbon R1 and R2. So this compound can show geometrical isomers because there is lone pair there is this bond there and R1 and R2 there. So this can go either this or pH, NH and double bond C, R2 above, R1 below, and lone pair here. So it can form two compounds here.
Right.
So the crux here in the question is we have to react the reactant. We have two reactants and we are getting three products.
Yeah.
So how do we get this? We can get a hint that one product might give two and one give one.
Yeah.
So which will give one? Which the product which have R1 is equal to R2. Like both the groups are same, then these two products will be same.
Yeah.
Like pH, NH and
R.
Yeah, R. No matter how do they react, R1 above R2, they are both same. So we are getting three products only if one of them has symmetry about double bond O. Like both groups are same and one have different. So that's the main crux of the question. Like we have to find this. So look at the first option A. It has same group on the both side. So it will give one product.
Yes.
This also have same group on the both
that
side.
Will also give one product.
So we will get only two products.
Right.
So that's not our option. In this only this compound B, only D form is given. Only one compound is there.
What do you mean only D form?
Only D, because this compound, look, this compound is chiral.
Right.
This is optically active. So this may be in D form plus L form, maybe.
Right.
So if D form, because this compound is unsymmetric about this double bond O, so it will react like this pH, NH and double bond, like Me will be above or Me will be below.
Right.
So there will be two different products, product number 1, product number 2. So if this form is D form, it is also in D plus L, this is also in D plus L. So actually we will get 4 products.
Okay.
So here only D form is given, so only mean only one product is there.
Okay.
So only this only D form will be formed here in this question. So only 2 products, only due to unsymmetry about this double bond, not due to unsymmetry about this chiral carbon.
Okay.
And this is simple HH, both same.
Yeah.
So this will give one product. So this will give 2 products, this will give 1 product, so 3 products. This meets our criteria of 3 products. So this might be our answer. Look, always remember that why it's good. आपने पूछा अच्छा है काफ़ी ये क्वेश्चन, अगर डी और एल फॉर्म दोनों होती तो इसके डी और एल फॉर्म दोनों का प्रोडक्ट बनते दोनों, तो 4 प्रोडक्ट्स बनते टोटल. अगर यहाँ डी प्लस एल दोनों फॉर्म होती तो मेरा डी प्रोडक्ट के करस्पॉन्डिंग 2 प्रोडक्ट्स बनते और एल फॉर्म के करस्पॉन्डिंग 2 प्रोडक्ट्स बनते. सो टोटल प्रोडक्ट्स विल बी 4 + 1 5.
Right.
Agar if D and L form both were given. Look here in the C option, both are identical group, no unsymmetry.
That will give one
product. Here groups are different, so it will give 2 products. So it also meets our criteria of 3 products. So it will be also our answer. Look at the 4 option D. Here it is chiral carbon and nothing is written, so we have to assume both the forms D plus L. So like as I have discussed it before, D form as it unsymmetrical about this atom.
Yeah.
So N double bond.
Yeah.
This will be different.
Yeah.
So D form will give 2 products and L form will also give 2 products. So
Yes.
4 products for this, and this is also unsymmetrical about.
So 2
Because-
products
yeah.
with that also.
So this is also unsymmetrical. One H and one PH group.
Right.
So unsymmetrical. So this will go 2 products. So the total products for option D will be 4 plus 2 is equal to 6.
6.
So the only options which meet our criteria of
B
products
and
are
C.
B and C.
Right. So in these sort of questions, when we've asked to find all products, all reactants that give 3 products, so we just have to match each reactant and put it in that place and try and see what products it will form.
Yes.
Okay. Here we have another matrix match type question, and we've been asked to match these given pairs to chain isomers, position isomers, metamers, and functional isomers, or they could be identical. So how do we go about identifying these isomers?
Yeah, this is pretty simple and straightforward question, but still we have to हमें ध्यान रखना पड़ेगा कुछ चीज़ों का यहाँ पे. तो यहाँ पे देखना फर्स्ट पार्ट देखते हैं सबसे पहले ए पार्ट. ओ ए पार्ट क्या क्या लगता है ये रोटेट करके बनाया या इनेंशियोमर टाइप कुछ तो नहीं सोच रहे आप? नहीं, ऐसा कुछ भी नहीं है. ये एक्चुअली सिमिलर कंपाउंड है, बस इसको रोटेट कर दिया ऐसे. लाइक ये कंपाउंड इस प्लेन में था, लाइक ऐसे NH2 ClOH. मैंने क्या किया, इस कंपाउंड को XY ZX इस Y इसे मैं बोल रहा हूँ Y एक्सिस, ये है मेरी X एक्सिस. तो मैंने X एक्सिस के अबाउट Y एक्सिस के अबाउट इसे रोटेट करा है 180 डिग्री.
हाँ.
सो मुझे से ये कंपाउंड मिल गया. तो
हाँ.
सिर्फ रोटेशन से मुझे ये कंपाउंड मिला है, किसी और तरीके से नहीं. तो ये एक्चुअली आइडेंटिकल कंपाउंड से मैंने कुछ रिलेटिव पोजीशन चेंज नहीं की है किसी भी ग्रुप को हटा के. ऐसा नहीं किया है मैंने कि इस ग्रुप को हटा के यहाँ लगा दिया है. बेसिकली ये सिमिलर कंपाउंड है. सो दिस आर नॉट पोजीशन आइसोमर्स, दिस इज आइडेंटिकल. सो A goes with T, these are identical.
Okay.
In the second part, I am asked like basically 3-membered ring, ethyl group on each, and this 2 methyl groups on each. So what should be these
Is
two?
it a functional isomer?
No functional isomer because they both are alkanes and
Okay.
so
there is no functional
isomer.
group on it.
So they are not identical because I have seen that they are changed in the structure like methyl, ethyl. So what are they? As we know from the chain isomer definition of chain isomer, the size of
The
main
longest chain will differ.
Yeah, main chain, size of main chain, and size of
Substituents.
substituents or side chains should be same. Should be same in position isomers. Sorry.
Yeah.
So if they are position isomer, they should have same length of side chain, but they are not. So they must be chain isomer because size of main chain and size of side chain is differs in chain isomer.
Okay.
So they are chain isomer because size of side chain is here 2, here 1, 1.
Okay.
So they are chain isomer. So B
Right.
part is done. Now moving on to C part. Here NH is joined with this PR is propyl group.
Yeah.
Like C, 3 C carbons are there.
Yeah.
And here ET and Me. So this is the most important and tricky part. People get confused here. They think it is metamer because in metamers we know some compound from here
but
shift
shouldn't
from
it be
here.
functional isomer because
Yeah.
these amines are
Yeah, amines because this is 2 degree amine and this is 3 degree amine.
yeah.
So these are not metamers. These are functional isomers because degree of amine is changed here. 2 degree amine, it is 3 degree amine.
Right.
So this is functional isomer. Don't make a mistake here. Don't take metamers here. This is functional isomer S. Now moving on to D part. We know now this is like 3 carbons on this side and 1 carbon on this side. 1 carbon jumps from here to here. So here 2 carbon remains and 2 carbons here. So this is an example of metamerism.
Okay.
So these are metamers. So now I should take on metamers, not before R. So this and D option is R. So always remember 2 degree, 3 degree and 1 degree amines are
different functional groups.
Different functional groups. So they are considered in functional isomers, not in metamers.
Right. So when you go about talking about isomers, chain isomers are basically different size of main chain or substituent chains. Position isomers are they have main chain and side chains as the same, but only the positions are different.
Yes.
Metamers are could you explain some more about metamers?
Basically they have two actually metamerism is shown by the compounds like N H. Like take NH, there are 3 carbons here, 2 carbons here, and one same group are here. So
okay.
If I like 4, okay, so this is my first compound, this is my second compound, NH C C C C C. One carbon jumps from here to here, one carbon jumps from here to here, jumped from here to here. So these 2 compounds have different the main functional group should be same.
Right.
For metamerism.
So metamers are positional isomers with one carbon being different in position.
Yeah, different because the metamerism is shown by the compounds which have the capability of having more than one side chain. Like ester group, we can ester group we have either side chain here also, side chain here also. So they have 2 side chain, and so they can be different. In the number of carbon atoms. So they are considered as metamers.
Okay. Here we've been asked IUPAC names of the given compounds. Oh, the IUPAC names are basically naming conventions.
Yeah, there's no trick involved in this question, but still the questions can be very interesting.
Okay.
Like, look at the first question.
Okay.
Let me check whether this compound is called alkyne or alkene. So that may be a tricky part. Students may get confused. What is this compound? So as we have studied in our theory part, we know that if a compound contains alkene and alkyne both, then the compound is termed as alkyne, but numbering is done is such a way that it gives alkene priority.
Okay.
So this is my basic concept of this question. I have to give priority to alkene.
This will be 2 ene and 3, 4, 5 ine.
So termed as alkyne, but numbering is done from the alkene. So my first, second, third, fourth, fifth, 6, 7, and the rest of the part is same. If I write the name of the compound like this is like simple chain. So first my ion is present on 5, so I am writing its name down here. 1, 2, 3. 4th, I have a methyl group on 4th. So 4 methyl. And the main chain contains 7 carbons. So hept, because hept is the
7
name for 7 carbon numbers. Now I have alkene at second carbon, so 2 ene. And the tricky part is I have to ene first and ine in the next 5 ine, because the compound is termed as alkyne, but numbering is done from alkene. So this is the concept in this question. And for the second part, like for the this is simple alcohol, phenol, and this is aldehyde. So as we know, aldehyde is given preference over phenol. So this will be termed as aldehyde, and this will be treated as substituent.
Right.
So this will be termed as side chain, first carbon, second carbon, third, fourth. So this group will have name 4-hydroxy. and as it is a substituent, it is added before this thing. What is this? Math eth 1 2 main chain
Okay.
numbering. I am doing main chain numbering.
Right.
1 2 math eth ethanol, because I know ale is the
Mhm.
suffix for
Aldehydes.
aldehydes. So this compound will be named as 4-hydroxyethanol. In the C part,
Hmm.
the same thing, alkene plus this group, phenol. Now, as this is phenol is given preference over
Alkene.
alkene. So
Okay.
here, because the number 1 2 3 4, there are only 4 carbons in this, where the if alkene has more than 6 carbon, then the preference would be given to alkene, but here the number of carbons are less, so
Okay.
preference will be given to phenol. So
Okay.
it will be termed as phenol. So
Okay.
I am written down phenol first. Which position at phenol? First position is this, second is this. So at the second position, it is attached, this substituent.
Okay.
So what is the name of this substituent? I have to number it first, like first this, second, third, fourth, like I have done before. 1 2
Yeah.
3 4. So this its name is, no, this would be wrong actually if you see.
Why is
because
that?
because I have to give this substituent in the alkene.
Hmm.
I have to what do you think? The numbering is correct or not?
I don't know actually. As in, shouldn't you start from the nearest carbon to the phenol
no,
group?
actually, as if I see this ring,
Hmm.
what would actually this ring is now a substituent.
Hmm.
So the substituent, the minimum position is given to the carbon which is attached to main ring, not
Right.
the alkene. So this thing which I have done 1 2 3 4 is wrong actually. Is
Okay.
it to confuse you? So I have to done the numbering from here 1 2 3
Okay.
4, because this is the main point, because minimum the preference
Hmm.
will be given to,
Closest to the main ring.
yeah, which is close to main ring,
Hmm.
main chain,
Yeah.
what we call. So here the main chain is this, so minimum preference will be given. So the name of this side ring would be but 3-enyl,
Okay.
and it is attached to its second position, like here.
Okay.
So it is
Two-
second phenol.
Okay.
So this will be the correct. So always remember, I have done the part to confuse you, like whether this is correct or not.
Okay.
You have to ask yourself, then make it confirm that this is the right numbering. So always ध्यान देना है इस बात पे.
Okay, so when it comes to IUPAC naming, always we end up taking the longest chain, or if the longest chain is actually less preferred to another functional group.
Yes.
Okay, so once we've identified the longest chain, we identify the substituent compounds.
Yes.
Right, so we write the substituents first, and then we write how many ever numbers carbon atoms are in the longest chain,
Yeah.
followed by ene or ine or an.
Yeah. Simple rules of the IUPAC nomenclature, which
Yeah.
you have to remember, and basically it is not as important topic as the isomerism. So
Okay.
this is asked very rarely in the JEE syllabus.
Oh,